Hi, and thanks for coming back. Today's video is going to be on making a spindle lock. Um, so at the moment, I've got to use two spanners on here, and it doesn't allow me to hold the tool. And sometimes when I loosen off the collet nut here, whatever tool I have in the chuck sometimes drops out, so just becomes a little bit tricky there. And it would be a lot better to be able to lock it and be able to remove, loosen this nut off and remove and replace the tool, particularly when you have a lot of tool changes that you're doing on whatever work you've got. So for example, the Hosfield bender, the holes that I was drilling into those bars for the frames, I'm starting off with a small drill bit and working my way up to the sizes I need. And I just want to drill all the holes for that particular one and then move over to the next one and start again. So there were a lot of tool bit changes that needed to be done, and it was a little bit tedious and a little bit hard. And as I said, when I've got two hands on the two spanners, I don't get I can't really hold the piece or the tool bit that's in here, and sometimes it falls out, which is never any good. So here's a shot of underneath, and what I need to do here to loosen the nut and tighten the nut up is put the spanner on the top piece there, and then use the ER32 collet spanner on here. So that's fine, and it works fine when you're changing a tool 2 times a day. But if you're doing work where you need to change a tool many times, then it becomes a little bit of a pain in the backside. So the plan is to do something similar to what the other YouTuber did and make up a block that bolts onto the ring. Fits in here and is cut out and has a metal bar in it to go into the slot here, and be able to push it in and push it out so that we can just lock it with a turn of a lever. But just looking around right now, I don't actually have any aluminium that is suitable for this, so I'm going to have to actually cast some and make a block up that will be wide enough and long enough to do the job here. As you saw, I finished casting the aluminium block here. The next step is to mill it all down and square it all up, as in squaring up a block. And the holes are quite far apart. That's why I had to cast this kind of wider block here. So the width is pretty good. There's actually another round piece, I don't know if you can see it there, but underneath, so it will actually go down, and in there it'll basically have a recess cut in here, so it can go back up and be flush on this top plate here. And then I just need to work out how far in we go, and maybe it was a little bit longer than what I anticipated here, so we might have to chop a piece off here and maybe shape the edges in a bit so it's not so bulky and clumpy. But a little bit of sort of working out what to do next here. It's a wild and windy night here tonight, so if you hear a bit of noise in the background, that's just the wind and the rain. So as you saw there, I milled the block up, so I've got it in a kind of a rectangular square cube shape there at the moment. So that's coming out pretty good. There's hardly a little teeny tiny mark there where it didn't clean up properly, but other than that it was a very good casting, I think. We'll see how good it is in the middle once we start milling into it a bit further. Anyway, I've printed off some screenshots of the video that I have in the description there of the other guy that's built one of these spindle locks. And he actually has a very similar mill to what I've got, so it's pretty good that you know, his design will probably work pretty good with my mill as well. And the video, I think it's in a different language, Russian or something like that, but you can certainly turn on the subtitles and see what the guy is saying in English. And he actually says in the video that it's exactly the same reason that I have, you know, where you've got two hands on the spanners and the tool drops out and falls down onto the vise or whatever, and you can damage your tool. So basically this spindle lock will give, you know, a free hand to hold the tool while you loosen off the ER32 nut. So he had a scrap of aluminium with a hole already in it, the large hole there, and you know, he just sort of machined it up to fit. Now my piece here is a little bit wider. You can see that his is longer and probably skinnier. You know, his might be only about that wide there. But mine's a bit wider. It's because the holes that I have in my, you know, the ring that goes around the spindle are wider apart than what he has on his one. So that's why I had to make it a bit wider. But what I might do is, where it bolts on, I might taper it in a little bit narrower down here where the big hole will be, this big hole here. So we'll see how that works out a little bit later on when we get to that part. And on this image here, you can see this is where it goes up. So this is the top face, and you can see he's cut a little bit away here, and that goes around, you know, the spindle bearing housing, so it sort of fits in there. So I think that's what I'll start with on the block here, is I'll work out what radius this is, and I'll see if I can use a fly cutter to cut into that and to get the correct shape. And once I've done that, then I can hold it up against the spindle bearing housing and mark out where the holes need to go. At the moment they're through holes, so I'm going to have to tap the you know, the spindle ring with a thread in there, but I'll be able to mark out where the holes need to go in the block before I tap it out. And then once we've cut that chamfer out here, then we'll work on where we need to drill our big large hole here to allow for the centerpiece that goes in here. You can see the centerpiece is in here, and there's a rod that screws into that centerpiece, and then basically he uses that as a lever to pull around this groove, and as he pulls it around the side, it engages the metal prong into the spindle to stop it from moving. So that's the mechanics of it. Now his centerpiece here is made on a 3D printer, and I do have a 3D printer, but I'm sort of work out what I'll do with that maybe closer to the time. It might be just as easy to turn up a piece of steel and put it in there. block machined up very well, so it's all there, bolted and secured on there now. And I did actually take some more off this surface here. So this was pretty much almost touching the chuck here. But I do actually have a drill chuck that fits in here as well, so Morse taper 3. And it's a lot wider than this, so I think I've taken enough off here that I'll be able to get that drill chuck in here as well. So you can see the recess in here. This is where we want our pin to come through and go into this hole here. So basically this block is probably about twice as deep as it should be here. So what I'm going to do is I'm just going to go down probably a little bit below this bottom ledge or collar here, and I'm going to draw a line across here, and then I'm going to chop the bottom part of this block off, and that will give me a lot more room around this area where I need to tighten the nut. And if I've got the chuck in here, I can tighten that up as well. And I will be milling out under here. Once this is chopped off, I'll be milling out the face under here for the plunger that comes through into this recess here. And of course that then needs a cap on it, like the other guy on YouTube, the way he designed his one. So the question is, do I use the leftover aluminium for the cap? I'd have to mill it down quite a lot, so it's a lot of wasted aluminium. Or do I use something like a bit of 1 or 2 mil panel steel and just put a cap on and bolt it on? So some decisions we have to work out maybe a little bit later on. So I think the next step is to cut this off here, and then I can start working on milling out the hole that goes in the top here for our lever that we can move around, and also the recess for our plunger that needs to slide in and out here. Right, we've got the centre milled out there, and this is the slider or pin. It fits in here, very nice fit in there, so it's hardly any play at all. And it's just slightly below the face here, so there will be a a cap, probably not this, maybe a bit of panel steel, which will be put on the top here, or actually it's the bottom, so it goes on that way, and it'll be bolted on here, maybe even a couple of holes up here, but that slides beautifully in there. So basically what we need to do now is we need to cut a piece of this out up here, because there's going to be a spring that fits in there and stops on this piece of steel and stops on this piece of aluminium. That's just to stop this thing accidentally engaging, you know, vibrating round to slide in. So the spring will push back pressure onto it and it will hold it out. And we've got the hole here, and basically there'll be a piece of steel that goes in there, and we'll do an offset turn on the lathe. So basically we'll turn the outside down, offset, so that we have a little I don't know, it's about an 8mm diameter stub that will be on there, and you just cut a slot in here close to where we need it, 8mm wide, and then basically that stub will come through the slot, and then as you turn it round, it'll push it forward, and as you turn it back, it'll pull it backwards. The slider machined up very well, and that all works out pretty good in here too, so it's very nice tolerances. Spring goes down in there, and it flies off somewhere around the workshop and I have to go find it. We'll try that again. Okay, so yeah, that piece fits in there, spring fits in there, I'll put my finger over it this time, and that just slides in there. There's absolutely no play in there, so it's a nice machining fit. So the last piece of the puzzle is the bit that rotates around, and that will be cut on the lathe, offset, so that we get a little bit of a piece coming up the top here, and that will fit into the slot here, and then as we turn it round, it pushes it back and forth. So I'll work on that piece next. So I've got the spindle lock bolted on there, and that works absolutely nice, so nice and smooth. You just need to line up the hole in here. So basically, if it's not lined up, you're only going to go out to halfway here, and then you'll just turn the spindle until it engages. Bring it right round to there, and then that's pretty much locked up. Then you can load in your tool, and you can just tighten it up with one hand now. But the key thing here is actually getting the tools out. So now I can actually hold the tool, take it off with one hand, and the tool's not going to, you know, fall out and get damaged onto the vise there. That's a great little improvement for the mill, so very happy with that. Thanks for watching.